Welcome everyone. Today we're diving into a significant paper in the field of human-computer interaction titled Research Contributions in Human-Computer Interaction, written by Wobbrock and Kientz in 2016. This paper provides a comprehensive overview of how research in human-computer interaction, often referred to as HCI, is categorized and classified, which will be the foundation of our video today. HCI is essentially the point where humans and technology meet. It's all about understanding how we, as humans, interact with machines, and how we can design those interactions to be more user-friendly, efficient, and enjoyable. You can think of it as a partnership between people and computers, where our goal is to create systems that work for people, not the other way around. Although it's a relatively young field, HCI has grown rapidly and now spans across multiple disciplines, including computer science, psychology, design, and more. Each research paper in HCI is like a puzzle piece contributing to the bigger picture. To understand this better, we classify knowledge contributions into different categories or types of knowledge. Let's break them down. First, we have empirical contributions. This is like when scientists observe and collect data through experiments or interviews. These findings help us understand how people interact with technology in real-world settings. For example, a study might observe how people use a new app to understand what works well and what doesn't. Empirical studies in HCI come in various forms, each suited to different types of questions and contexts. For instance, Burke et al. Used interviews to understand how adults on the autism spectrum engage with online communication. This kind of in-depth qualitative data helps us uncover personal, often hidden experiences. In contrast, Cherwinski et al. Used a diary study where participants tracked their daily task-switching behaviors over a week. This approach allowed the researchers to gather detailed, real-time insights into how people manage interruptions in their work. Lab experiments, like those conducted by Li and Zhai, take a more controlled approach. By systematically testing factors like button size and feedback on touchscreens, they gathered precise quantitative data on user performance. This is valuable for making concrete design recommendations. On the other hand, Poltrock and Gruden opted for a qualitative field study, immersing themselves in real software development teams. This allowed them to observe the real-world challenges in interface design, offering insights that wouldn't have been captured in a lab setting. Each of these methods, whether interviews, diary studies, lab experiments, or field observations, shows the diverse ways empirical research can be conducted depending on the type of data and context we're exploring. Next are artifact contributions. This is where designers and engineers create new tools or systems, much like inventing a new product. For example, if someone designs a virtual reality headset that makes it easier to experience immersive environments, that's an artifact contribution to HCI. Artifact contributions in HCI are all about designing and creating new technologies that improve the way we interact with computers. Let's look at a few examples. Bowdish et al. Developed the SOAP device, an innovative pointing tool that works in midair. This new input device offers flexibility and precision across different applications, showing how hardware can be redesigned for novel interactions. Similarly, Dixon and Fogarty introduced Prefab, a system that enhances graphical interfaces by reverse engineering pixels, offering a powerful way to implement advanced interaction techniques in existing applications. We also have Greenberg and Fitchett, who created Fidgets, a hardware toolkit that makes it easy for developers to build physical interfaces. Fidgets simplify the process of developing physical computing systems, opening the door for more rapid prototyping in HCI. In another example, Grossman and Balakrishnan introduced the bubble cursor, an input technique that dynamically resizes the cursor's activation area to make target selection more efficient, especially in crowded interfaces. This is a great example of how input techniques can be enhanced to improve usability. Finally, Ishii and Ulmer took a visionary approach with their tangible bits concept, exploring how physical objects and ambient media can be used to interact with digital information. Their work demonstrates not only physical artifacts, but also an entirely new way of thinking about HCI, bridging the gap between the physical and digital worlds. These examples highlight the diversity of artifact contributions in HCI, from physical devices and toolkits to innovative input techniques and visionary concepts. Then we have methodological contributions. Think of this as creating a new tool set or approach that helps researchers or designers do their jobs better. For instance, someone might develop a new process for testing how users interact with a website more effectively. Methodological contributions in HCI are vital because they give us the tools to better understand user experiences and improve system design. Let's explore a few examples. Consalvo and Walker applied the experience sampling method, a technique from psychology, to evaluate ubiquitous computing systems. This real-time sampling allows researchers to capture user interactions with technology as they happen, providing valuable insights for evaluating systems that are meant to blend into everyday life. Druin pioneered a new approach called cooperative inquiry, where children actively participate in the design of technologies made for them. This innovative method brings users into the design process from the start, ensuring that their needs are met more effectively. Similarly, Millen adapted traditional ethnography into a faster, more agile method called rapid ethnography. By focusing on key informants and using multiple observers, Millen's method provides deep insights into user behavior, but within shorter time frames, making it more practical for today's fast-paced design cycles. Lastly, Sukarev and McKenzie developed new metrics for evaluating text entry performance. Their unified error metric offers a more nuanced understanding of how users handle errors during text entry, which helps researchers improve keyboard and typing technologies. These examples show how methodological contributions, whether applying, adapting, or creating new methods, are essential for advancing research in HCI. Theoretical contributions come next. These are frameworks or models that help us make sense of what we observe. Imagine writing the storyline for a movie. Theories guide us on what might happen next and how different pieces of information fit together. Theoretical contributions in HCI give us the frameworks and models we need to better understand and predict how users will interact with technology. For example, Bellotti et al. Provided a thought framework with 5 key questions that designers should consider when creating sensing systems, especially in ubiquitous computing. These questions help us anticipate interaction challenges in systems where users might not always be aware of the technology in use. Card et al. Took a different approach by mapping out the design space of input devices, offering a framework that helps researchers categorize and evaluate input technologies. This framework not only makes sense of the wide variety of input devices, but also guides the design of new ones, ensuring they are both expressive and efficient for users. On the societal side, Nathan et al. Introduced a set of envisioning criteria to help designers think about the long-term and systemic effects of interactive systems. Their criteria, focused on stakeholders, time, values, and pervasiveness, encourage designers to consider how technology impacts individuals, society, and the environment far beyond its immediate use. Finally, Wobbrock et al. Extended Fitz's law by developing a new error model for pointing tasks. While Fitz's law traditionally focuses on speed, Wobbrock's model accounts for errors, providing a more complete framework for evaluating user performance in pointing tasks. This quantitative model is particularly useful for designing precise interaction techniques, where accuracy is as important as speed. These examples illustrate how theoretical contributions provide critical structure to the research and design process, helping to guide innovation in HCI. Another type is dataset contributions. This is like compiling a large collection of data which other researchers can use for their work. For example, a massive dataset of how people use mobile devices across different countries could be a valuable resource for others studying user behavior. Dataset contributions are essential in HCI because they provide standardized resources that allow researchers to evaluate and compare different systems and techniques. For example, McKenzie and Sukarev developed a phrase set of 500 predefined phrases for evaluating text entry techniques. This standardized corpus allows for consistent comparison of different text entry methods across studies, making results more generalizable. Myers et al. Took a different approach by creating a set of benchmark tasks for evaluating user interface toolkits. These benchmarks represent a range of UI styles and allow both students and developers to assess the strengths and weaknesses of different toolkits. By implementing these benchmarks in various toolkits, researchers gain a clearer understanding of their effectiveness. Payek and Shu proposed a corpus procedure that generates representative phrase sets for text entry experiments. Their approach ensures that the phrase sets reflect modern usage patterns, such as those found in email or social media, making text entry studies more relevant and accurate. Researchers can use their procedure to create custom phrase sets for different domains, providing flexibility while maintaining methodological rigor. Finally, Plaisant et al. Contributed to the field of information visualization by creating a benchmark repository based on contests at the IEEE InfoVis Symposia This repository allows researchers to systematically evaluate and compare visualization techniques using a shared set of tasks and datasets. By providing standardized benchmarks, they help the field progress by enabling meaningful comparisons between different visualization methods. Each of these dataset contributions ensures that research in HCI is consistent, reproducible, and comparable, allowing the field to advance through shared resources. Survey contributions are all about summarizing existing research and finding patterns. This is like taking a step back and analyzing the overall trends from a bunch of individual studies to see what we've learned and where we need to go next. Survey contributions in HCI are critical for providing comprehensive overviews of the state of the art in specific areas. Let's explore some examples. Balakrishnan conducted a technique survey on methods for enhancing pointing tasks in graphical user interfaces, showing how virtual environments can beat Fitts' law by artificially reducing target distance or increasing target size. This survey offers valuable insights into which techniques work well and where improvements are needed, particularly in environments with multiple closely spaced targets. Johnson et al. Conducted a tool survey on computational support for sketching in design, reviewing existing tools that help designers manage the ambiguity of early sketches. This review provides a roadmap for improving sketch-based design tools, making it a crucial reference for researchers and developers working on sketch recognition systems. In their domain survey, McKenzie and Sukarev examined text entry techniques for mobile devices, providing a detailed overview of models, methods, and best practices for evaluating text input methods. By covering both research and commercial products, this survey helps researchers understand the key challenges and opportunities in designing effective mobile text entry systems. Lastly, Scher and Hornecker conducted a technology survey on tangible user interfaces, TUIs, exploring how physical objects can be used to manipulate digital information. This extensive review covers the history and future directions of TUIs, offering insights into the strengths and limitations of this emerging interface technology. Each of these surveys helps researchers and practitioners understand the landscape of their field, providing a consolidated resource that summarizes past work and points out future challenges. Lastly, we have opinion contributions. These are essays or discussions where researchers share their personal views or critiques of certain trends or ideas in HCI, often sparking new discussions or debates. Evaluation is a critical component of HCI, allowing researchers to assess the effectiveness of systems, designs, and methodologies. Let's look at some key examples. Bernstein et al. Examined the challenges in evaluating social computing systems. They highlighted how traditional evaluation methods may not fully capture the complexity of socio-technical systems and called for new approaches to address issues like misaligned incentives and unrealistic expectations. Dorish took a closer look at the role of ethnography in HCI and challenged the idea that ethnographic studies should always result in design implications. Instead, he argued that the evaluation of ethnography should also consider the broader insights it provides into human behavior, beyond just direct applications for design. Greenberg and Buxton provided a critical evaluation of usability testing, suggesting that while usability evaluation is important, it can sometimes hinder creativity, particularly when applied too early in the design process. They encourage designers to be more thoughtful about when and how to evaluate usability, especially for radical innovations that might not fit existing norms. Finally, Newell and Card offered a visionary evaluation of how psychology could contribute to HCI. They predicted that psychological science would play an increasingly important role in understanding and designing interactions, and their call for more rigorous integration of psychology into HCI has shaped the field's development ever since. These evaluation contributions show how evaluation in HCI goes beyond just measuring usability or performance. It involves questioning assumptions, refining methods, and guiding the future direction of research and design. In conclusion, understanding these different types of knowledge helps us navigate the field of HCI. It gives us a framework to think about how we contribute to the growing body of research and helps us communicate our findings in a structured way. As you continue to explore HCI, I encourage you to keep this spirit of inquiry alive. Who knows, you might contribute the next great idea that shapes the future of how humans interact with technology.
Thanks for watching. I hope you find this video educational and informative. If you like this video, please subscribe to my channel. See you in the next video.